Hello, I am Preetius. I am practicing at JSS College of Arts, Commerce and Science, Ooty Road, Mysore. I am going to explain about the topic potentiometry. Potentiometry is the field of electroanalytical chemistry in which potential is measured under the condition of the no current flow. It is the method of analysis in which we determine the concentration of solute in solution and the potential difference between two electrodes. Potentiometry is an instrument that used for the determination of the unknown concentration between the reference solution and the sample. Involved in the potentiometry is when the pair of electrode is placed in a sample. The solution is to show the potential difference by the addition of the titrate. Metal atom may dissolve in the solution as positive ions leaving electrode on the electrodes. Metal ions may take up electrodes from electrode and get deposited as a neutral atom. In this way, a potential difference is set up between the electrode and the solution. Theory involved in the potentiometry. When the known potential electrode immersed in a sample solution, then the potential is given by the Nernst equation. E is equal to E naught plus 0.592 divided by N into log C, where E is the potential of the solution, E naught is the standard electrode potential, N is the valency of the ion, C is the concentration of the sample solution, 0.592 is the value obtained from RT divided by F, where R is the gas constant, T is the temperature and F is the Faraday. We can use two electrode in the potentiometry. One is the reference electrode, another one is the indicator electrode. Mainly involved in the potentiometry are reference electrode and a calomel electrode. The reference electrode mainly useful for determination for the analyte by maintaining the fixed potential. For example, standard hydrogen electrode, silver chloride electrode, saturated calomel electrode, and the reference electrode classified into two. One is the primary standard electrodes and a secondary standard electrode. Primary standard involved in the standard hydrogen electrode. Secondary standard electrode involved in the silver chloride electrode and saturated calomel electrode. Another one is the indicator electrode. It is used to measure the potential of the analyzed solution comparing with that of a reference electrode. Its potential is directly proportional to the ion concentration. For example, hydrogen electrode, glass electrode, antimony oxides electrode. There are two types of indicator electrode. One is the metal indicator electrode, second one is the ion selective electrode. Metal indicator electrode, these develop the electric potential. It responds to redox reaction on the metal surfaces. Platinum or the used to metal indicator electrode. They are mainly classified into three electrode used in the potentiometry. One is the first kind of electrode. They are composed of the metal rod immersed in a metal solution. These electrodes correspond to the ionic activity of the electrode. Example, silver electrode dipped in a silver nitrate solution, copper electrode dipped in a copper sulfate solution. Second kind of electrode, these are composed of the metal wires coated with the salt precipitate. These electrode responds to the change in the ionic activity through the formation of the complexes. Examples, silver chloride, potassium chloride, mercury and mercurous chloride, potassium chloride. Third kind of electrode, these electrode are also known as the inert electrode and redox electrode. These are composed of the inert metal electrode immersed in a redox solution. For example, platinum hydrogen electrode. Electrode, standard hydrogen electrode, it consisting of the platinum wire in an inverted glass tube. Hydrogen gas is passed through the tube at 1 atm. A platinum foil is attached at the end of the wire. The electrode is immersed in a 1 mH plus ion solution at 25 degrees Celsius. The electrode potential of SHE is 0 at all temperature. The second one is saturated calomel electrode. It is commonly used reference electrode. It consisting of the glass tube that containing mercury at bottom covered with solid mercurous chloride, and above this the tube is filled with the KCl solution. A platinum wire is in touch with the mercury and it is used for the electrical contact. The potassium chloride solution inside tube can have the ionic contact with solution outside and act as a salt bridge. The electrode potential of SCE is plus 0.2422 volts. One of the potentiometry, we taken here two solution. One is the zinc chloride, another one is the silver nitrated. The zinc rod dipped in a zinc chloride solution, a silver rod dipped in a silver nitrate solution. These two rods are connected by the potentiometer, and these two solution is connected by the salt bridge containing the potassium chloride. The zinc rod represented the anode, and the silver rod represented the cathode. For potentiometry, first we have to switch on the instrument and connect the saturated calomel electrode for the positive terminal and the glass electrode to the negative terminal. Arrange the calomel electrode and pedal of the stirrer in such a way that it must be a lower level of the glass electrode which is placed between them. Adjust the meter to 0 and standardize the electrode system. A subsequent reading are to be taken with the stirrer motor running. Rinse the beaker and electrode thoroughly with water, then with the solutions to titrate and place a measured volume in a beaker. Add sufficient water to cover the bulk of the glass electrode adequately. Switch on the stirrer and measure the pH of the solution. Add 2 ml of the titrate. Allow sufficient time to mix and measure the pH of the solution. Add further quantity of the titrated as the end point is approaches, reducing to 0.1 ml increment and measure the corresponding value of the pH. Obtaining further reading of the pH for about 5 ml beyond the equivalence point. Switch the meter to standby and turn off the stirrer. Wash the beaker and electrodes thoroughly with the distilled water. Plot a graph of pH versus titrate added. Read off the equivalence point from the graph and calculated any required data from this value. If the titrated is of weak acid against the base, calculate the pKa value of the acid from the Henderson equation, which is valid over the range of pH 10 to pH 4. For potentiometry, the clinical chemistry, ion selective electrode are present sensor for clinical sample because of their selectivity for analyte in complexes matrix. The most common analyte are electrolytes such as sodium, potassium, calcium, hydrogen and chloride, and dissolved gases such as carbon dioxide. The environmental chemistry for analysis of the ammonium nitrate in water and wastewater. Potentiometric titration for determining the equivalence point of an acid-base titration. Possibles for redox titration, precipitated titration, acid-base titration, complexometric titration, as well as for the all titration in aqueous and non-aqueous solvents. As for agriculture purpose, the ammonium iodide, calcium, potassium nitrate, chloride in soils, plants, material, feedstuff, fertilizers, etc. For the determination for manufacturing detergent like calcium beryllium fluoride for studying the effects in water quality and the other food processing also we can use the potentiometric titration. Thank you.